Okay, we have a right triangle with a hypotenuse equal to 5, and the other sides are consecutive integers. So we want to find the lengths of those two sides. So the first thing that we're going to do is we're going to draw a little diagram of the situation. So I'll draw just a right triangle. Does not have to be accurate. And I want to label it with the information that I'm given in the problem. So I can see that the longest side is the hypotenuse, that's 5. The other two sides are consecutive integers. So if we let one of those integers be x, the next one after that will be x plus 1. Because to get from one integer to the next integer, you add 1. So I'm just going to say, let's let that side be x, then that side will be x plus 1. So now that I've labeled those sides like that, I want to look for a relationship between the sides, and of course it's the Pythagorean theorem. So I'm going to say this, x plus 1 quantity squared plus x squared is equal to 5 squared. So in the Pythagorean theorem, the sum of the squares of these two sides is equal to the square of the hypotenuse. So that gives me this. So that's from the Pythagorean theorem that I get after I label that little triangle. Now I need to solve this equation, so I'm going to start by expanding this, x plus 1 squared, x squared, plus, don't forget the middle term, 2x, plus 1 plus x squared is equal to 25. So remember, when you take this x plus 1 and square it, you're going to get x squared plus 2x plus 1. So as a way of review, remember a plus b, quantity squared, is always equal to a squared plus 2ab plus b squared. You have to have that middle term. So we've done that correctly right here. Most common mistake I see with this problem is in this step right here, this is x squared plus 1, no middle term. Okay, so now I'll collect the x squared, so that's 2x squared plus 2x minus 24 is equal to 0. So x squared plus x squared is 2x squared. There's my 2x. I have a positive 1 here. I subtract 25 from both sides. I get minus 24. Now I see I have a least common factor here of 2, or greatest common factor of 2, so I'm going to divide both sides by 2. And on this side I get x squared plus x minus 12 equal to 0 divided by 2 is still 0. So I have a quadratic equation. It's in standard form with decreasing powers of the variable on one side, 0 on the other. So I'm going to factor it into x plus 4 times x minus 3 is equal to 0. Now the only way this product can be 0 is if one or both of these is 0. So if the first one is 0, I get x plus 4 equals 0, which means that x is equal to negative 4. If this one is 0, x minus 3 is equal to 0, then x is equal to 3. Well, x is a side in this triangle, so it cannot be a negative number, so I'm not going to allow that solution. That means that my solution for x is 3. I'm asked to give the lengths of those two sides, so what I'm going to say is this. X is equal to 3, so x plus 1 is equal to 4. So the three sides in that triangle are 3, 4, and 5. I can check to see if these solutions are correct by using the Pythagorean theorem. Is 3 squared plus 4 squared equal to 5 squared? Do I actually have a triangle? Can I actually form a triangle with sides of those lengths? Well, that's 9 plus 16 is equal to 25, and so 25 equal 25. So yes, there is a triangle that has those for sides. Okay, so what do? We have a problem like this. We draw a little diagram, doesn't have to be accurate, of a right triangle. Start labeling the triangle with the things we know. First of all, the hypotenuse is 5, so that goes right there. The other two sides are consecutive integers. So one's going to be x, the other's going to be x plus 1. Suppose it said consecutive odd integers. Well, one would be x, and the next odd integer after that would be x plus 2. So you have to know those things from algebra to be able to label these two sides. Once you have that, it's simply an application of the Pythagorean theorem. Then I use my knowledge of algebra and quadratic equations to solve. I end up with x equal 3. That tells me that the other side is 4, and so I have a 3, 4, 5 right triangle.